Hello, I'm Pushkar, Master Teacher in Vedantu in Chemistry. I'm going to discuss advanced problems, JEE Advanced 2020 Chemistry problems. So let us discuss the problem, question number 16. Let's go through the problem. In this problem, aluminium reacts with sulfuric acid to form aluminium sulfate and hydrogen. The reaction can be represented as aluminium plus H2SO4 changing into Al2SO4 whole thrice plus H2. What kind of reaction is this? This is obviously a redox reaction. This is a redox change. So in this redox change, aluminium is getting oxidized, and if you see the oxidation number of aluminium is 0 and oxidation number of aluminium in this is plus 3. So aluminium is getting oxidized and hydrogen is getting reduced. If you see carefully, in H2SO4 there are 2 hydrogen in +1 oxidation state, and here the oxidation state of H2 is equals to 0. So you can calculate the N factor of H2SO4 in this reaction, which is due to H, and it will come out to be 2, and the N factor of aluminum will come out to be 3. Now the question is, by what method we would like to solve this problem? So I think that we should solve it by both methods. Let's try by both methods. First, let's try the mole method. So in the mole method, you have to balance this equation. Balance equation is aluminium plus H2SO4 is forming Al2SO4 whole thrice plus H2. To balance it, multiply 2. Aluminium is multiplied by 2 and sulfate is multiplied by 3 by heat and trial method, and hydrogen is obviously then 3H2. If you see, the mass of aluminum was 5.4 gram, and which comes out to be 5.4 upon 27 is equals to 0.2 mole. And if we see the amount of H2SO4 present here, so that is coming out to be 50 into 5, which is 50 into 5 is equals to 250 millimole. So if we keep in mind these quantities, we can say we have 0.2 mole of this and we have 0.25 mole of H2SO4. So obviously the limiting reagent is H2SO4. If you see this, if you divide 0.2 by 2 is 0.1, you divide 0.25 by 3, that is 0.08 something. So obviously this one is bigger, this one is smaller. So the limiting reagent is H2SO4, and which gives you quickly the result that mole of H2 formed as in this reaction is equals to 0.25 mole. Of course, then you can convert it into pressure by using the expression that P is equals to in the volume, is equals to nRT by P. And we can refer to this calculation to find it out that this is going to be 6.15 liters using this value of R. So this method is mole method. How to do it by equivalent method? Let's see how to do it by equivalent method. In equivalent method, we'll not balance this equation. We'll simply write the products Al2SO4 whole thrice and plus H2. As we have already seen, the N factor of this was 3, the N factor of this was 2, and we have already seen that this is 0.2 mole and this was 0.25 mole. So by equivalent concept, calculate the equivalent of aluminium, and the equivalents of aluminium will be 0.2 into 3 is equals to 0.6 equivalents, and equivalent of H2SO4 will be 0.25 into 2 is equals to 0.5 equivalent. Obviously the equivalence of H2SO4 is less, that means this is limiting, so 0.5 equivalent of this will form 0.5 equivalents of H2 gas, and that will give you 0.25 mole of H2 gas. Obviously the formula used here is equals to number of mole is equals to number of equivalents divided by N factor. So these are the two methods by which you can approach this problem, and I feel that the mole method is much simpler as compared to equivalent method. Equivalent method is not very difficult, but then you need to know the n factor very quickly. You should be very good at finding the n factors and the changes in oxidation number in the chemical reactions. So I hope that you enjoyed this solution. Stay tuned for much detailed discussions of these questions with us. Thank you.